That'd be good. Okay, remove my keyboard. And so any object, okay, so this is what we call projectile motion. Projectiles are like, I don't know, you kick a soccer ball, or like, I don't know, you hit a tennis ball, anything. Like we would have done this with, we would have called this a projectile motion, maybe not formally, but when you guys did quadratics in grade 10 and all the parabolas and finding max and mins and completing the squares and all that work, that's all projectile motion, right? When you throw a ball and it follows a parabola, right? So that's what we're just going to put it into words. So any object that moves in response to gravity along a two-dimensional curved trajectory is what we call a projectile. I'll use red so you guys can see where I've written. Okay, and the motion of a projectile under gravity is called what we call a parabola. There should be a little a here, called a parabola. Right, which can be described by a quadratic mathematical model. So you guys, this is why maybe some, like when we teach quadratics in grade 10, quadratics is a kind of it's like promotes critical thinking for all kids, which is what we're trying to do. It doesn't necessarily have the biggest applications for kids in real life as much as, like, say, financial math would, like exponentials. But for those of you taking physics, like, you need this work, right? And so if we're talking about quadratics, keep in mind that you have some skills in dealing with quadratics already, right, from grade 10 math. And in the 3U math, you would have taken that even further and applied it to rational variable expressions, right? The weird looking graphs that did something like this. You guys would have done stuff like that, right? So it's important to know, okay, we have two distinct motions going on here, and which is why, this is what I alluded to at the very beginning of today. We have horizontal motion and we have vertical motion, right? Every projectile is going to have motion in the x separate from motion in the y. As soon as you're able to distinguish or break apart that in your head, the questions start to become a little bit easier, okay? And so what I want to do here, underneath x and y, and what I'll do is I'll try and follow the same color code from yesterday, okay, where we broke things into components. I just want to make a list of things that we could find, or things that we know in the x direction for a projectile. Okay, so in the x direction, we have something called, we'll call it a dx, or delta dx, right? And we'll call this like the range. The range, if you guys like the way I would remember this, is like a driving range. It measures how far you can hit something horizontally, right? So it's the range, right? If I look at this picture down here, this is the range. How far from the base of the building, delta dx. Okay. The second thing we know, or could find, we could have velocity in the x direction, right? So that would be the horizontal velocity. Okay, and then we can find time, but you guys know there's something special about time, and time is going to be your friend for these questions. Something special about time. Does anybody know what it is? Or what it is I'm kind of referring to here? With something being special, you guys can drop it in the chat if you want. Okay, when I say there's something special about time, yeah, good, Willow. It's the same, right? Time was a scalar, right? We listed that, right? The very first day we were talking about vectors versus scalars. Time is scalar. So you're going to use this to your advantage, right? It doesn't care if you're in X or Y. Time is time, right? And so you're going to use that. We're going to use that continually for this. That's kind of the key to these questions, okay? So you've got time, right? And there's one other thing. You know the acceleration for a projectile, this is something new, maybe you guys don't know, is always 0 in the x direction. This means as soon as you give something a velocity, it no longer accelerates unless it has like a motor or something on it, which it's no longer a projectile. It has constant, like, there's no acceleration. It's just constant velocity in the x direction. There's nothing, I mean, I suppose wind resistance could slow it down, so there would be a negative acceleration in that instance, but we're not going to deal with questions like that, right? All our questions in projectile motion are going to deal with negligible wind resistance, right? And so we're assuming that the acceleration in the x direction is 0. So the velocity in the x is not changing, right? We're going to have constant. So are we okay? And remember, this is for projectiles. This is not like a car on the ground. Obviously, a car on the ground is going to have acceleration if it's braking or speeding up, right? This is for things flying through the air, okay, that you make this assumption. Okay, so let's jump over to the y. Well, delta dy is what we could call height. And so what you might see is some people, even myself sometimes, could label this h, delta h, a change in height, okay? And then we could also have the vertical, the vertical velocity, or velocity in the, vertical. Okay, and then we already know from our work on Friday, acceleration in the y. Okay, and the last thing we already know, t for time, sorry. Okay, these two time values, the same. It's the, we'll call the time is the, I'll write in black. It's the shared variable. Okay, so we're going to use this to our advantage in order to pivot between y and x. It's going to be like this variable that I can switch between solving for things in the x direction and solving for things in the y direction, right? Time is your best friend for these questions. Okay, and we have a few different ways to calculate what time actually is. Okay, does anybody have any problems with that so far? What I like to do with all these, the reason why I set it up like this initially is I always say I like writing down what I have and what I'm required, right? So at the start of all of these questions, I just like to break down all the information that's given to me, right? And it visually allows me, oh, I need this. Okay, well, I can put the pieces, almost like a puzzle, eh? Where you're like trying to piece it all together. Okay. Do you have any questions? If there's no questions, I'll jump down and we'll try the first question here, okay? AY. Jagger, the acceleration, we learned this last Friday. This is just a known. So when you drop something, or the bullet, right? But when they drop the bullet and fire the bullet, that's the acceleration that an object feels due to gravity. Like gravity is pushing down on it and causing it to accelerate at this number of 9.8. Negative, well, it's accelerating in the downward direction, so it's negative 9.8 meters per second, okay? So it's just a known. You just know that always for projectiles. Like, this is a given, pretty much, right? You know always that, unless stipulated, so for instance, if this question was on Mars, then I tell you what the G value was, right, for that particular question. Okay? It doesn't change anything, it just changes this number. Okay, you're still going to solve these questions the exact same way, just with a different number here. Is that okay? I'd have to tell you that. If it's on Earth, I don't have to tell you. You guys just know that, right? It's 9.8 meters per second squared, down. Okay? Now, what you'll notice, and I think this is maybe one of the key differences between maybe like what I would classify a grade 12 question versus a grade 11 question. If you guys look here, there's something nice, like you got a part A and part B, and typically if I would give you a question like this, you need what we'll see after this question. We need the time in order to be able to do this question. That's a kind of a nice question, right? This is what I mean by scaffolding the questions for you guys so that you could do one thing at a time and be able to use it, right? A grade 12 question might just say, a beanbag is thrown from a window 10 meters above the ground with an initial velocity of this, right? Okay. They don't ask you A, right? A wouldn't exist. They would just ask you part B. And so you'd have to go through the thought process of how do I need time in order to do whatever I need down here. That would be like, in my experience, that's where questions get a little bit more difficult, right? Because there's not, we'll call it a breadcrumb trail for you, right? You just kind of, you got to know how to get like from point A to point B or your answer, whatever it is you're interested in. Sometimes you got to solve for intermittent things, right? Time typically with these questions is the intermittent thing, right? Because it's shared between both of them. Okay, so what you'll see is like most of these questions that we do today, solve for time. Time, right? So if you're in grade 12 wondering, oh, this is like, these questions look easy. Well, they're scaffolded, right? But there's really not much of a difference between a grade 11 question and a grade 12 question, right? Aside from the fact that we're not leaving the breadcrumbs, right? There are other ways which are done in the grade 12 question, the 4 U's. You'll see in your homework questions that things get a little trickier. But for the most part, in my experience of doing these questions, time is like your best friend. If you guys can solve for time in these questions, that's half the battle. Okay, it's because it's shared between the two directions. It's a shared number. Okay, so if you're ever stuck, like really stuck, just solve for time. Because I'd probably say most of the time you're going to need it. Okay, and so you'll at least get some part marks. Okay, if it's not provided to you. Okay, so let's just do this. Okay, so what I like to do, I'll use the red. In the X direction, I have, in this particular question, I know it tells me what Vx is, right? The initial velocity in the X direction, right? So I know VI, X, VI for initial, and in the X direction is 3 meters per second. Okay, I'm interested in how far did it land, so delta dx is the thing I want to know. And time, oh, I don't know time. Okay, that's what I know and what I don't know. Okay, great. Let's jump over to y. The great thing about this too is that you guys have, you just have lots of information, right? Things that you can figure out. Well, it looks like, right off the top, it looks like I know what delta dy is. Now, just pay attention, because I remember this messing me up too all the time. And it makes a difference in your answer because you end up getting a negative answer versus a positive, which is a problem if you go to square root a negative number, because you can't square root a negative number. So you might be like, you start freaking out. So it's the change in dy, right? What do we say the change is? D final minus D initial. This is why I tried to emphasize this on the very first day when we were counting displacements. It's the D final. Well, where does the ball end up, or whatever it is, the beanbag? Where does it end up? It ends up down here at 0. So df is 0, and D initial is 10. So delta dy is 0 minus 10, right? So we get negative 10 meters, which basically means it's 10 meters down from where you started, right? If we're using this reference frame of up, down. Okay, is everybody okay with that? This throws a wrench in things all the time. Even me doing some of these questions sometimes, I'm like, where's this extra negative coming from? Chances are it's this. Okay. That's where it comes. You gotta look at where it finished and where it started. That's what delta is. It's change. Right? Well, your change is negative here. Right? It went down 10 meters. Okay? You also know AY equals negative 9.8 meters per second squared. And you also know this thing here we'll see in the next question how to deal with something like this, but it's not moving up anywhere. It doesn't have an initial velocity in the y direction, right? It just got fired horizontally out the window. It didn't get fired at an angle, right? It doesn't have a velocity upward. So you know v1y equals 0. Okay, and what's the thing you're after? Time. I don't know. Well, if I find time, then I could find, well, it's the same time, and now I can find dx. That's the second question. So you can see how being able to share time between both directions here, it's a useful tool. Okay, so you guys this is like step one. It's a question from Friday. You're asking yourself, how long is it going to take for this thing to hit the ground? Once you know that, you can find how far did it go from the base of the building. That's the question. That's projectile motion. It's separating the two directions and solving appropriately for what you need, okay? So let's just do that. We just need to go to our sheet, which you guys should see on, I continually come back to this. We don't need this anymore. I come back to this all the time, where I go, okay, this sheet here, I'll try and create a formula sheet for you guys as well for reference, but that lesson where we had, it was Friday, you guys go into the lesson, there are your 5 equations that you need for this work. Okay, and so what you gotta pick an equation that allows you to solve for time easily, right? So I think the equation that works best here, and I'll do the work in blue because that's what we're working in the y direction right now, right? I'll pick delta d is equal to v1yt plus half at squared. Okay, does anybody have any objections to the equation I've selected? Okay, it looks like I can check off all this stuff, right? I know v1, I know a, right? That's what you're trying to do. Well, you're just going to plug stuff in now. So you know delta d, negative 10. Negative 10 is equal to v1, we said was 0. Didn't have an initial velocity up, right, in the y direction. It's 0. And that's going to be equal to 1/2 of negative 9.8 t squared. Right? What do you get? You get, just going to isolate for t. You can do that any way you want, right? As long as you get the right answer. So, you can just do the math if you want. I don't care. Negative 4.9 t squared. So t is going to equal negative 10 divided by negative 4.9, so t squared, sorry. And t will equal the square root of 2.04. So are we okay? So it takes 1.42 seconds for the beanbag to hit the ground. Okay? Well, if that's the case, well, time doesn't care what direction you're moving in. So it also took, okay, well this thing's falling in the x direction. Right? How long did it fall? It fell for 1.42 seconds. So how far? I can find how far then, right? Say, okay, well, we know that dx. Yeah, I'll create one, Christopher. Sorry. Actually, I have one created, and I'll share it with you. Okay. I'll share it with you guys. Okay. Just so you guys don't have to keep bouncing back and forth. I'll find it and post it today. Okay. I've been doing that. It works okay for me. I just bounce here, but you guys will need a big formula sheet as we get through the units. Okay. So I'll post that. I think we're at the stage where we need something like that now, okay? So we find, okay, dx is equal to v x times t. All right, well, dx is going to equal, what's vx? Vx, or vix, v initial x, 3 times, how long did it take? 1.42. What's that answer? 4.3. Okay, so therefore the beanbag (4.3 meters). Okay, are we okay? Nothing too crazy? Just keep in mind, I think that the most important thing that I don't think really got conveyed to me when I was learning this, well into grade 12, and I told you guys my story of grade 11 physics. Like, the guy who taught me grade 11 physics retired the next year, so I didn't really care too much, right? He was on his way out. So there was a lot of us entering grade 12 physics that were just like absolutely lost, right? And so the physics teacher that I had, and I kept the binder, had to consolidate what had happened the year before. Like, a lot of us knew nothing. So we had to basically start over, right? This is a good, unique situation that we're all in, because I think for the most part, I don't know when you guys took math. It was forever ago, right? For some of you, I don't know. Some of you took physics in first semester of last year. That was forever ago as well, right? So that these kind of questions, this binder is perfect for that. You get a bit of an exposure of where are you guys. We'll kind of give some easy questions, and then we'll move along to some harder stuff for the 4U's, right? You guys get an idea. So I've been in your boat. Okay, here we go. A soccer player running on a level playing field kicks a soccer ball with a velocity of 9.4 meters per second at an angle of 40 degrees above the horizontal. Okay, so here's what you got. This is where the work from yesterday comes into very, very important. It told you, and I'll go switch to black here. It told you what the velocity vector was, VI. VI was 9.4 meters per second. It did not specify, and what did kind of specify, that the angle at which, but I mean the direction, I suppose. I guess it gave you the direction, okay? What you need to do, that's useless to you, right? From the standpoint that you need to be able to solve these questions in both directions, like vertical and horizontal, right? That's how we solve these things. This is useless information to you, the way it currently sits. Okay, just this idea of this. You can't use that in the question. That's the resultant vector. So what you guys need to be able to do is take that resultant vector, this VI, and break it into its two components, which is what I showed you yesterday, for the exact reason of what we're doing today. Right? So when I write down Vx, or sorry, x, let's just deal with the x direction for a minute. Okay, I'm after the time of flight again, so it's basically the same idea from before. Okay, it just proposes a different challenge now, because now this thing's been fired or kicked with some initial velocity in the y direction. So we need to figure out what that is. Remember, the other question was just fired horizontally. Okay, so let's find, we need to find Vix. Well, how do I find, if I know that this is the angle 40, how would I find this? You guys know? Hopefully. If not, I'm sure you know, we just can't have made the connection yet. How do I find what the x component is? You guys want to drop it in the chat? If not, I'll just move along. I've only got 20 minutes, so I got to get through these questions. Okay, to find that, I showed you guys yesterday. Well, this is a right angle triangle. Well, x is adjacent and y is opposite. Yeah, good, Elizabeth. Okay, so Vx, is it just cos 40 though, Elizabeth? You got to take the magnitude of the vector, 9.4, and multiply it by that, right? So your V1x vector, this vector here, is 9.4 cosine 40. It's cosine because you have the hypotenuse. Let me just show you where that comes from. We need cosine 40 is equal to adjacent over hypotenuse. How do you get the adjacent? X is what I'm after. You multiply both sides by hypotenuse. Well, you know the hypotenuse is 9.4. Okay, that's where that comes from. So you guys can give me an actual number, right? You can do the math on that. Turns out to be, let me scroll down here. I'm not typing in stuff. We get 7.2 meters per second, right? That's the value. It's the magnitude. Well, I suppose it's the x. It's the 7.2 meters per second in the x direction. It's a vector. Okay, it's acting in the positive x direction or east. Okay, and then you guys can go, okay, I don't know dx, so that's what I'm kind of after. That'll be the range, right? Part B. So dx is going to equal question mark. And you also don't know the time of flight. Okay? So t equals unknown. Okay? So let's jump over then. We're obviously going to solve for time in the y direction, right? That's what we just finished doing in the last question. So we're going to have v1y is equal to 9.4, the opposite of cosine, and now we're standing at opposite. Well, you can do the same work. It's going to be 9.4 sine 40. Right? And I can get a number. That's going to be 6.04 meters per second. Okay, I don't know t again. I do know something though. I know the ball started on the ground and finished on the ground, so I know delta dy is 0. And you also know the given, that this thing's accelerating at negative 9.8 meters per second squared. Okay, so I'm going to work in the blue direction to find time. The same way I did earlier. All right, we're going to solve for t in the y. Okay, so we're going to pick delta d is equal to VIYT plus half AT squared. It's the same work as the last question, right? With the exception that this time V1Y is not 0. Right? There's a little trick here. So but we know delta D is 0, right? Because it starts on the ground and finishes at the ground. So delta D is 0. So 0 equals, we're just going to start throwing in numbers. We know V1Y is 6.04 T plus 1/2 negative 9.8 T squared. Right? You could do the math on that, and then you would get 0 equals 6.04 T minus, right? It's minus because this is minus 4.9 T squared. Now, everyone's sitting freaking out. They're like, oh boy, here we go. We know what this thing looks like. Could we do something to this? Okay, remember I'm trying to solve for t. Okay, and let's forget about physics for a second because the physics is almost over. Right? This is a math. Let's just put our math hat on for a second and look at this. How on earth would you guys get t by itself here? Well, I see one term here, and I see a second term. Right? In each of those terms, I see a t. At least one. So I can go like this. I can factor out a t. I'm going to get 6.04 minus 4.9 t. Okay, well, what's that do? Well, this 0 over here is very convenient because I can divide both sides by t. And look at that. The t basically consumes that, or the 0 consumes that t, and look where I'm at. 0 equals 6.04 minus 4.9 t. Now you can solve for what t is. Right? You can say, I don't know, I don't care if which one you move over. I'm going to move this one. Okay, I'll say, okay, I'm going to move this to the other side so I can create a zero pair by going plus 4.9t, plus 4.9t, right? And so what do you get? You get 4.9t is equal to 6.04. Divide both sides by 4.9. T equals, what number did I get? 1.23 seconds. All right, so we now know, okay, this motion, this soccer ball took 1.23 seconds to go up, get kicked, and come back down to the ground. 1.23 seconds, okay? You can use that piece of information now. That's part A. That's the answer for part A. You found the time. Okay? Range. How far did it go? Well, you now know in the x direction, it's the same time. So you now know it's 1.23 seconds. So now you can go, okay, well, dx is equal to vx times t. This is part B now. You say, okay, dx will be equal to, what's vx? Well, in the x direction, the velocity was 7.2 seconds, or meters per second, sorry. And I multiply that by 1.23. Well, dx is equal to 8.85. Everybody freaking out right now? This is basically the same question we just finished doing, right? With a little twist, Okay, the twist is this thing's not being shot horizontally. Okay. Listen, the key. I think honestly the key to this, and this worked when I remember in grade 12 physics, is this: writing down what you know and you don't know. Okay, in both directions. This is kind of a, and then once you know you got to solve for time, you're just like, and it's not, it might not always be time, but it at least gives you a starting point. You look at what you got and what you're looking for. You just pick an equation and try to piece it all together, right, to answer the final question. We've got one more thing here. Just got to find the maximum height, right? Well, you guys know the max height for math is right here, right? It's the optimal value, okay? Right? What's true about the max height is, for a very split second, something reaches a maximum height, right? And it changes direction. We saw this on day one. When something changes direction, there is a split moment in time where the velocity, the final velocity we'll call it, v2y specifically, is equal to 0. Okay, it's for a very small second in time, when it reaches its maximum height, its velocity in the y direction is 0. What else do you know? You know ay is negative 9.8. You would technically know t. You could take the t value and divide it by 2. You guys could say that. I didn't actually do that for this question, because you already knew v1y was equal to 6.04 meters per second. That came from here. Okay. And then you know you want to find out what delta dy is, or height. All right, we'll pick an equation. I'm going to pick this one, vf squared. Well, it's vf in the y direction is equal to v1 or viy squared plus 2ad. We know 0 equals 6.04 squared plus 2 times negative 9.8 times d. Okay, I'll save us some time here. Just the normal solving. dy will be equal to 1.86 meters. Okay, so there's the max height. Okay? Okay, if you guys wouldn't mind just bearing with me, okay, we're probably going to go over time a little bit. I'm going to run quick through this question as quickly as I can, okay? I might finish in the next 9 minutes, but I don't know. That one took 11 minutes. I think this one, it might be like, I don't know. Maybe we'll finish at 11:05, okay? Does anybody have any questions with that one before I move to the next one? Okay, very similar to the last question in the sense that we had to solve for time and pivot through time, right? But with the exception that I had an initial velocity in the y direction this time. Okay? If you guys bear with me and we'll finish this last question, it's not much else I can ask you. This last one's a little tricky. Okay? This would be like an example of this would be a norm question for a grade 12 student, right? Maybe even a grade 11, depending on how I'm feeling, right? You guys have the skills to do this question. Okay, and you'll see in a minute. Okay? So a golfer is trying to improve the range of her shot. To do so, she drives a golf ball from the top of a steep cliff, which is 30 meters above the ground where the ball will land. Okay. If the ball has an initial velocity of 25 meters per second and is launched at an angle of 50 degrees above the horizontal, determine each of the following. Okay, so very, very similar with the exception of C. C is the only difference here between this question and the last question. And there's also a little hiccup in here as well that makes this question special relative to the last one, which we're going to see in a minute, okay? But the setup, when you guys look at these questions, you just get in the habit of saying, okay, what do I know in the X direction? What is it I'm looking for? And what do you know in the Y? And what is it I'm looking for, okay? So for this question, I know the initial velocity is 25 meters per second. Okay, so I know that Vix is going to be V1, V initial, cosine theta, right? That's the formality that you guys need to know. And for these kind of questions, it doesn't really change. Okay, so you say, okay, well, what's VI? It's 25 cosine of, what angle did it get launched from? 50. And that number should be 16.1. This is going to go on the whole page. This is a big question, okay? You also need to figure out dx equals, I don't know, and t equals, I don't know. Okay, so let's jump over to the y then. There's not much to do. You might get lucky and tell you the range. That would be a nice question because then you can solve for the time and jump over to, that'd be an easy question, easier. There's just different scenarios of things that you can solve for, right? So V1y is equal to V1 sine theta. So we're going to get 25 sine 50, which is going to equal 19.2 meters per second, okay? We're going to come back to that stuff. Delta dy, for the same reason, it started up here and finished down here. So it's height, negative 30. It was nice in the picture and told you that. So it's negative 30 meters, right, for that one. T equals, I don't know, AY is going to equal negative 9.8 meters per second squared. Okay, any issues? Questions, comments, concerns? Here's what you know and what you don't know, okay? All right, so here we go. Solve for T. This is an interesting question though. Okay, we're going to solve for T and Y. Okay, so here we go. I'm going to pick this equation. Delta dy equals V1 y delta t. It's again more and more convoluted. You don't really need the delta t. T is t. Plus 1/2 ay delta t squared. You don't need the delta. Ooh. Okay. So let's just start throwing in information. Negative 30 is equal to, we know V1y is being 19.2 t plus 1/2 of negative 9.8 t squared. Okay, so just to simplify things, 19.2 minus 4.9t squared. Now, you guys will notice, what is the difference between this question, and this is what makes this question more difficult. Not more difficult, but it's just more of a pain, right? What makes this question different from the last one, or the one before, this is not 0. We did not shoot the ball from down here on the ground. This throws a wrench in things. It's not that you guys don't know how to do this, it just throws a wrench in it. What does that do? Well, if there's a 0 here, you saw how easy it was just to factor out a t and then solve. That was a nice question. You cannot do that here. That's a problem. We're stuck. You're relying on something. Does anybody know what it is we're going to rely on? I'm going to rewrite this for a second and see if it prompts anybody. Okay, so all I did was bring things over to the other side of the equal sign and their signs switched. Does anybody know what's going to happen? Yeah, our handy friend, the quadratic equation. Right? You guys can solve for t here using the quadratic equation. You guys know how to do that. If you don't, in Minds Online, for your benefit and convenience, if you guys need a brush up on quadratic equation, there's a lesson there, okay, for my math class. You guys can go watch that if you need it. Okay, I'm going to run through it here anyway, but if you guys need to do a couple more questions, there's a lesson there, a video lesson, okay? So here's what we need. We need t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, it should be noted at this point, I don't really care how you guys solve this, right? I just want kind of the answers, right? Most calculators, they know the calculator I had at Mac, it was a Casio something 591 or something. It had the quadratic equation built in. So you could go, okay, calculator, quadratic, what's A equal, what's B equal, what's C equal? It'll spit out the two answers. I don't care if you do that. I'm sure there's something online that'll allow you guys to do that. Yeah, I don't expect you to do this every single time. Just for, it's not important, right? It's just recognition that you need it and that it's a tool, right? I'm not going to mark you on your math skills on quadratic equation. That's not the point, right? For the purposes of this lesson, I'll write it down just to show where everything came from. But it's not the point. I don't care how you guys get the answer for this. There's tools out there. I don't know if anybody's ever shown you this. Different calculators are different too. It's not just one way. Otherwise, I just show you. And some don't have it. Minus 4 times 4.9 times 30, negative 30. All divided by 2 times 4.9. If you guys need to see where those numbers come from, go watch that video. You'll watch one question and it'll make sense, okay? I highlight, well, you can see where the numbers go. Okay, so you're going to see that t should equal, and I'm spilling onto the next page, I know, 19.2 plus or minus 30.930 divided by 9.8. You're going to get a t value that is negative 1.97, or t equals 5.15. Now, it does not make sense. You cannot have a negative time that's going back in time. But the only person that could do that was Marty McFly. Okay? Can't do it. Doesn't make sense. So you ignore it. So here's your answer. So therefore it took the ball 5.15 seconds to reach the ground. Okay, part B is easy. It's the same part B that we've been working on for the entire lesson today. How far did it end up going? dx is equal to vix times t. Vix is 16 meters per second. So it's 16.1 times 5.15. 82.9 meters. That's how far it went. Okay, now Last part to this question is kind of important. It's a little bit different. I'll try to get this done as quickly as I can, okay? The next 5 minutes. Shouldn't take 5 minutes. Okay. We're looking for what we call the impact. It doesn't say that there. Oh, it does say that. Impact velocity. Okay. The word velocity should prompt you guys to something. Right? Velocity is a vector. Okay. Which means you're going to need a magnitude, a final velocity as it hits the ground. But I also want to know which direction it was headed. Okay? And so you got to figure that out. So we need to find the magnitude. That's step 1. Okay? You guys know, we know Vx doesn't change, right? I said this at the very beginning. Right? For projectiles, as soon as you kick that thing or hit it, it experiences no acceleration in the x direction. This is constant. So you know what Vx is. It's the Vx from the very, very beginning when it got hit in the first place. Right? This number. So you know Vx doesn't change, so it's 16.1 meters per second. You know that. So what you need to find is what Vy is equal to. That's what you're after. V1, Vy final, I suppose. V final Y. That's what you're after. Okay. So let's find that. And this is going to be the magnitude, right? And we'll have to find the direction after. So here's the equation you can use. V2y squared, V1y squared, plus 2AD y. Okay? So we're going to get V2y squared is the thing I'm after. V1y, remember V1y is the blue velocity, 19.2. You're going to square that, plus 2 times negative 9.8. Sorry guys, I'm running out of room. Let me move this over a little bit or shrink it. That's why I love the iPad, because it lets me do that. Okay. Just solve for V2y. V2y squared, or V2y, should be 31.1. Alright. Mr. Mackay, what are we doing with this? Okay, you guys know, and I showed you this yesterday, you guys know how to do this. I'm going to jump down here for a sec, okay? You know the x piece is this. It's 16.1 meters per second in the x direction, positive x, right, in the east. It's 16.1 meters per second, east. No, you guys don't have a lesson at 1 o'clock today, okay? So that's kind of the trade-off here. Okay, I posted the review. You guys can go work on the review. I'm going to try and mark your formatives while you guys do whatever. If you need help, you can drop in, okay? So I'll just finish this, and then this is pretty much it for this unit. Okay. And then you guys just found what the V2y was, how fast it was traveling in the y direction. Well, the impact velocity is this. The black vector. This is V impact. Right? So what do we have to do? Well, you know too, this looks awfully familiar to me. Right? Awfully familiar. Oh, 90 degrees. I'm just going to find that. How do I find that? You're going to go x squared plus y squared equals, I don't know, V squared, right? So you're going to go 16.1 squared plus 31.1 squared V squared. You should get that V is equal to 35 meters per second. So this is V impact. I won't label that. Be final velocity or something. Okay. It's 35 meters per second. Almost done. You know the magnitude of the velocity, but you don't know. Okay, I'll upload it, Brody. You can see it at the end, okay? I got one little thing left anyway. You probably know how to do it, okay? I got to find the direction, theta. That's it. Find theta. Because you guys know you need a magnitude, a number, and you need a direction for a vector, an impact velocity. Okay, so what are you going to do? Tan theta is equal to opposite over adjacent. Here's your theta. Here's opposite. There's adjacent. So you say, okay, 13.1 over, oops, not 13.1, 31.1 over 16.1. And then the theta is actually going to be equal to tan inverse of 1.93. And theta will equal 62.6. Okay, last step, write your vector. So this means that the V impact is equal to 35 meters per second. You're heading in the east direction. East. What's the angle? 62.6 degrees. Which direction did you go? South. You came down in the south direction. There is, put a little arrow on it, your final answer. That is it. I'm sorry that took so long, but that's it.